Okay, here what we're going to look at is how do we use these base 10 block things where this means 1 whole and this means 1/10 because it's 10 times smaller and this means 1/100th because it's 100 times smaller than this, or 10 times smaller than this, to do multiplication and division. And this is where, honestly, I learned by having to do it 40,000 times. It didn't really click as to why the pieces were working. Literally, I'm sitting at a conference as a 37-year-old teacher. Somebody breaks apart these decimals with base 10 blocks, and my eyes light up and go, oh, if somebody showed me that in 5th grade, it would have saved me hundreds of hours of sitting at the kitchen table making my parents miserable, going, I don't understand this. I don't understand this. Because doing the algorithm, which is just solving the math problem, didn't show me why it actually worked. It just said, here's the numbers, make it work. So if I'm going to do 0.4, or 4/10 times 3, I have 4/10 here. So to show a kid this, rather than just have them write down the number, now they've got something physical, they can hold on to it and go, yeah, this is 10 times smaller than this, and I've got 1, 2, 3, 4 of them. Well, what do you need to do in multiplication? 4/10 times 3 means 3 groups of 4/10, and that we all learned, because math teachers have been teaching that of means multiplication forever. So if I have 3 groups of 4/10, what I have is 1 group, 2 groups, 3 groups. So I have 4, 8, 12/10 when I put these all together. So if I have 12/10, that means I definitely have 2, 4, 6, 8, 10/10 that I can now trade in for a 1 whole. And that trade-in is really easy for kids to see, but if you're saying, turn your 10/10 into 1 whole, kids go here and blah, 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 yeah, use the bigger one. This is a change in place value. 10 of these means we bump up to our next place value, which is 1 whole. So when you see the math problem, 4/10 times 3 equals 1.2, or 1 2/10, what you're actually seeing is 4/10, 4/10, and 4/10 combined together to give you 1 whole and 2/10 left over. Or if you take out the decimal point, which is another way that we learn to do it as kids, you take out the decimal point, take 3 times 4, and get 12. Put your 1 decimal place back in there, 1.2. It all works the same way, but if you can touch it and trade out the parts, even as high school kids or adults like me, if I'm physically touching and manipulating the pieces, it's so much easier for me to go, oh, that's what those numbers mean while I'm using them. So let's talk about a division problem. Dividing decimals is not that hard with an algorithm, but it's not really easy. Kids basically just do what we tell them to do. If we say, here's the algorithm, they say, okay, and they have to look back at the algorithm and take notes on it, have notebooking, and say, oh, this is how my steps. Really what we're doing is say we're going to divide 2 and 3/10. Let's divide it by 3. Well, does this divide by 3? Not like it is. But can we change it so that it can divide by 3? Yeah, we can look at it as tenths instead of wholes. That means I'll need 5, 10. Now I can switch out 1 of these and get 10 of these. 5, 10. Now I can switch out this, and now what I have is 23/10. I know that I can make it into wholes, but I don't want wholes. I want groups. Because can I divide this into 3 stacks? Sure. 1, 2, 3. It's literally just, when I teach it to kids, it's literally just passing things out, like you would pass out a bag of candy. 1, 2, 3. Now I'm going to start doing it by 2 so that this doesn't take forever. Now I have 4/10 in each stack, but I still have some left over. Now I have 6/10 in each stack, but I still have some left over. Now I only have 5 left over, so I can't go by 2s. I can only do 1, 2, 3. So now I know in each group I have 7/10, but I still have 2 left over. What can I do with these 2 if I can't pass them out equally? I can do the same thing I did with my wholes. I can split these into one place value smaller. I can split these tenths into hundredths by saying, here's 1. Here, I split this into 10 equal parts for 1 100ths. Here's my second. Now I'm going to split that into 10 equal parts and get 20 hundredths. Now I can start passing these out again. So now I'm going to have 0.7, and each group now is going to have 0.71, or 72 hundredths, 0.72, 72 hundredths, we'll count by 2s now, 0.74 in each group, 74 hundredths in each group, 0.76, 76 hundredths in each group, and now I've got 2 more left over. So I'm going to bump down another decimal place. Now we don't have base 10 blocks for that because I'd have to take like an X-Acto knife and slice this into 10 equal parts and then hope nobody in my group that I'm working with sneezes because they're all going to blow away. But when kids can physically see that move down in place value, now they know I have 3 equal groups that I'm working with right here. And when I'm working with kids in class, I just circle them on a table and lay them out. But in each group of 3, where I took my 2.3, when I split it into 3 equal parts, I have 7/10 and 6 hundredths. And now I would have to bring down my thousandths and split that out equally. And when you solve the math problem along with doing this with the kids, they can see every time we have leftovers, it's that number that when you do your subtraction, you have leftover. I had 2 left over. So when I did my subtraction step in division, this is my 2 that I would have left over. And if I had another number up here, I'd bring it down, so it would be 23 hundredths if I had another 3 to bring down. So when I split this up, or when I split 2 of these up into these, I had 2. I didn't have anything to bring down, so I had to split these up into my hundredths. Hopefully, that at least can give you an idea. And I'm going to try to get the actual lesson, to try to get something I can record the actual lesson with, or try to get a kid to record it, just so that it can be a little easier to understand, and you can see what I'm doing when I'm working with actual kids and put that up, so that these videos can be for parents, because we remember what it was like to not understand math, because we're doing the same algorithm over and over. Kids don't get that because they're playing with pieces too. So hopefully I can get today a video of this lesson actually happening with kids so that you can see how they respond to it.